little star just to signify to restart recording. Okay, so the first one, so 3.2 well, it's going to give you something. Just the random example gave me was 9 to the 7 halves. So what you're going to rewrite this is 9 to the half times the 7th power. And then from here, you're just going to rewrite that as the square root of 9 to the 7th power, which will be 3 to the 7th power. And then 3 to the 7th power is 287. Or you can just open up Wolfram Alpha, and type in 9 to the caret 7/2. Okay. And that will also give you the same answer. All right, so 3.1.4, we'll do the same concept. We'll just do it slightly different. And so here, the random one my computer gives me is 432 to the minus 7th fifth power. So the way I'm going to do this is I'm going to write this as 1 over 243 to the 7th fifth power, because negatives means just drop it below. Here I'll have 243 to the 5th to the 7th, which is 1 over the 5th root of 243, which is 7. So the 5th root, so what to the 5th equals 243? You'll find out that A was then 3. So it means to find the 5th root. So this gives us 1 over 3 to the 7th power. What's 3 to the 7th power? We already figured that out. It is 1 over 287. Okay, so that's how you do those two. All right, so let's add a new layer. Let's go ahead and clear off this layer. Let's open up this layer. Let's mark this one is done and this one is done. So the next one you guys wanted to see was 3.1.13. And so this means 3.1 problem 13, not what the actual, this means 13 of the homework on the online homework, not the little number they show you, which is the homework in the textbook. Okay. All right, so let's go ahead and do that one. So let me open that up. 13. Boop. All right, so go ahead and give it a, oops, I'm writing on the wrong layer again. Oops. All right, so we'll just go ahead and clear out this. Right on the right layer. Clear this out. Click on this layer, and then there we go. All right, so here, the example my computer is pumping me. So 3.1 number 13 will give us, it says 6 plus I all over 7 minus 7 I squared. Okay. So this is what it gives me. So the very first thing we're going to want to do is find what 7 minus 7 I squared is. And to do that, we're going to just do 7 minus 7 times 7 minus 7I. All right, so what does that give us? So 7 times 7 gives us 49. So we minus 7I, or 7 times, so it's minus 49I minus 49I. And then minus 49, no, plus 49 times I, right? Okay. And so what do we have here? So we have, when we simplify this down, so this becomes minus 98I. This I, oops, I squared. This I squared just becomes a -1. The -1 comes up here. So 49 minus 49, which is, of course, 0. So I'll have 6 plus I over minus 89i. Okay. Now from here, we have a couple options to do. Let me see if I can explain the best way to do it, I guess. From here, you can just multiply on top by this conjugate, but here, all you really need to multiply by is by I, because if I multiply by I, I'll get rid of my I on the bottom. So if you have just an I on the bottom, just an imaginary, you can multiply by I over I. I over I, of course, is 1. So this times I would be 6I plus I squared. I squared is, of course, I'll just write it as I squared so I don't confuse you. And this will be minus 98I squared. Here, we're going to swap the I squares to negative 1s. And so the negative 1 is 98. Okay, and then from here, I can simplify by having negative 1 over 98. And then I'll have plus 6 over 98i. And then your computer wants you to simplify it as much as possible. Here, I can simplify by removing a 2. So it'll be 98 plus, I remove a 2. This becomes 49. This becomes a 3. So 3 over 49i. Okay, and so this is the correct answer, and this is what you can type into your computer. So what do we do here? When you see this squared, go ahead and square this. So I get 7 times 7, which is 49, minus 49i minus 49i plus 49i squared, just expanding that. So I get the minus 49 and the 49 cancel. So I just have negative 49 minus 49, so it's minus 98i. So that was what's on the bottom. So we just, this is just a longhand of simplifying what was on the bottom. If you only have an I on the bottom, a single, just an imaginary part, you can just do I over I to get rid of it. It's faster instead of doing 98i. So if I multiply I in here, I get 6i, I squared, and then I get negative I squared. Well, this becomes negative 1, so this becomes positive 98. The I goes here, and then I squared is minus 1. And then here I'm just splitting this up, so negative 1 over this is here. And this will be 6i over 98. And then I just cleaned it up. Okay, so that's how we do that one. Let's go ahead and mark this one as complete. On the right layer. All right, so let's do the next problem on our happy list. So 3.2.6. Let me open that up. All right, so 3.2.6. Where am I at? 3.2. Select. Preview. It's opening up. Problem 6. There we go. All right. So let's get rid of this. All right, so my 3.2.6. Notice your book list says a 3.2.5. So this is the number in the book. When I write out this, I mean 3.2 problem, and this is 6 of 16. So that's just in case you want to learn how to do that one. So it wants you to factor this. So 2x squared plus 3x minus 14. Okay. So the way I do this is well, for this one, it's probably, if this factors into rational numbers, I'll have a 2x on one side and an x here, and then I just have to play a more complicated game, I guess. So here if I have 2, so it'll be 2x and an x, or an x and 2x, so it doesn't matter which way I do it. So the factors of minus 14 are 1 and minus 14, negative 1 and 14, 2 and minus 7. and then minus 7 and 2. Okay. And so I want this to end up equaling 3 in the middle. And so what is it? So how do we play the game slightly different? Now I have to say, trying to think of how, I know how I do it in my mind, and it's kind of convoluted, but that's how they taught us back in the day. Some of you were taught this big X method. I don't know the big X method, so here I just list all the factors. So here's all the integer factors of 14, and luckily all the integer factors of 14 are not bad. I wrote the same thing twice, didn't I? Hi. This should be minus 2 and a 7. All right, so the one way of doing it is I want to get to 3. I want to get to positive 3. So my guess is I'm going to have a plus 7 somewhere and the minus 2. That's my guess. Because if I have a minus 14, say if I had minus 14 here, when I multiply these two together, let me just go ahead and write it in. So if I had a minus 14, when I multiply these two together, I'm at minus 28. So that definitely is not the answer, right? If I put in a minus 14 here, I'll get minus 14 plus 1. So that's still going to be negative. So that's probably not. If I have a 1 here, I'm going to be way too positive. So I'm guessing it's either 2, negative 7, or negative 2, 7. And since I want it to be positive, I'm guessing that the 7's positive. So if I put the 7 here and the minus 2 here, what do I get? Well, I'll get 14 minus 3. So that's too big. So I just want to do the opposite. So I'll do the minus 7 here and the plus 2 here. And so what do I get here? I'll get, plus 7 minus 2. Hold on. So here I'll get 7x and then minus 4x. Well, 7x minus 4x is what we want. And so that's how you do it. It's kind of messy, but once you have your front value not to be 0, it's always going to be messy. There's a different way of doing this, which we don't teach in this class, where you find all the integer factors and then you do polynomial long division in order to get it. Honestly, that's what I'd be doing at this point. But still, you can factor this. And so once you factor this, that means either 2x, this is equal to 0. That means either 2x plus 7 was equal to 0, or x minus 2 was equal to 0. That means 2x is equal to minus 7, or x equals to minus 7 halves, or x is equal to 2. So those are our two answers. So we have negative 7 halves or 2. And so this is your solution. So if you see this to be non-zero, just kind of write a couple factors here. And so you're going to have to play 2 games, right? You're going to have to find the factors of this and the factors of this. And then you add and multiply them to get them together. I think that's how the big X method works. I don't know. I really should learn that one day. Okay. So that's how you factor this. You can always check and enroll from alpha. Just tell it to factor and it'll factor it for you. Okay. All right. So let's go ahead and click this off. So we've done this one. All right. So the next one you want to see is 12. 12, 13, 14, and 15. So let's just kind of go through those. Add me another one. And get rid of this. All right, and let's open up 12. Boom. All right. So 3, 1, or 3, 2, 12. All right, so 3, 2, 12. So on mine, I'm seeing x to the 4th minus 21x squared plus 80 equals equal to 0. Here, we're going to do the following. We're going to set u equal to x squared. And so then this simplifies down to u squared minus 21u plus 80 is equal to 0. So we're going to factor this of u and u. So since this is a 1 up front, we know it's u and u something. So what about this 80? 80, oh man, there's a lot of factors. So let's just kind of list them out, I guess. So 1 and 80. -1, and -80. And so since we know that this is negative, we don't need to list the positives, right? Because it's either going to be both positive, both negative. This B is negative, so I only need to list the negative ones, right? So it's just going to be like -1, -80, -2, and 40, minus, doesn't divide by 3. It does divide by 4, 4 and 20. -5 and -16. 7 doesn't work, 8 doesn't work. 6 work? No. 7, 8 works, 8 and 10 does. And that's it. Okay, so this is it. So which one of these add up to be 21? Why, this set right here. All right, so I know I have -5 and -16 is equal to 0. Okay, so that's how I factored that. So now at this point, we're going to write u minus 5 is equal to 0, u minus 16 is equal to 0. Then we're going to plug back in what we know u is. And so we have u is equal to x squared minus 5 equal to 0. And I have u squared equal to -16 is equal to 0. Means x squared is equal to 5, or x squared is equal to 16, or x is plus or minus the square root of 5. Oops, forgot my equal sign. Or x is plus or minus the square root of 16, which is just the same thing as plus or minus the square root of 4. And so you just list them out. Your computer wants to list it out. So plus or minus square root of 5, plus 4. You don't need the plus. -4. And there you go. So that's how you do something that looks like this. So this is a common trick. You can convert things that are non-quadratic into quadratics by making a substitution, as long as whatever, if I have a variable and if I square it, I get this variable, then I can do that. And so let's do the next problem, which will show that in a little bit more detail. Actually, I'm going to move this up so I have more room. All right, let's get rid of layer 5 now. Try it on layer 6. Our next one here is I have x minus 3 square root x minus 18 equals to 0. All right, so here, and it tells you what to do. It gives you the hint to do this. So notice that this squared is this, right? So here I have u squared minus 3u minus 18. So whatever hint it gives you, just go ahead and plug that in. And so you should get some u squared minus 3u minus 18 and go from there. So let's do this. So we factored this. Which problem is this? Oh, I'm sorry. This is 3.1 or 3.2 number 13. So this is 13. So it's the 13th problem. It's listed. It gives you the number as 3.2.85. That's what problem it is in the book. Oops. Thank you. Thank you for your contribution. Go bye-bye now. So when I write 3.2, I mean 3.2, 13 of whatever. Okay. All right, so how do we solve this? So here, this is, we'll factor this. This is u. See if we can, and I think you know how to factor at this point. So let's just go for the answer. So this is u, u minus 6, u plus 3. Yes. This adds up to be -3, multiplies to be -18. Okay, so here I factored it equal to 0. So I have u minus 6 is equal to 0, or u plus 3 is equal to 0. Then we go ahead and plug back in. So I have the square root of x minus 6 is equal to 0, and the square root of x plus 3 is equal to 0. Notice that, and we'll go ahead and do the next one. So x is equal to 6, and then here I have the square root of x is equal to 3, or minus 3. Notice that this can never occur, right? The square root of a number can never be -3. If x was negative, I get an imaginary unit. If x is positive, I get a positive unit, so it can never be negative. So this is in here. And notice, remember the graph? Notice that negative values are just not included, right? And so this can never occur. And therefore you just throw this one away, right? You just say, okay, forget this one. Here, if I square both sides, I can say x is equal to 36, and that's your only answer, okay? So here, if you have the square root of x is equal to something, that never occurs, but this one can occur. So this one only has one solution of 36. And you can test it, right? 36 minus 3 times the square root of 36 would be 6, so it would be minus 18 minus 18. Yeah, that works out. Okay. All right, so let's do the next one. Wait, how did you get the 36? Oh, let's go back. I just squared both sides. So here I'm just squaring both sides. So the square root of a squared is x. 6 squared will be 36. Okay, all right. Good question. Let's do the next one. Boop. All right. So let's go ahead and do this one. And now we're going to, whoops, I'm writing on the other layer. Don't write on this layer. This layer is for this problem. All right, so let's do this. So we're going to do in 3.2.14 at this point. So 3.2.14. So here I have x to the 2/3 minus 3x to the 1/3 minus 4 is equal to 0. So it gives you the hint that x equals to the third power. So this is the squared. So this is u squared minus 3u minus 4 equals 0. So here, we'll factor this as u minus. That would be u plus 1, u minus 4. That's how this one factors. So I'll have u plus 1 equal to 0, u minus 4 equal to 0. Plug in what u is, so x to the, so it's the cubic root of x is equal to 1. Or plus 1, and then the cubic root, because x to the third is the same thing as the cubic root. So let's just use the cubic root. Oops, minus 4 is equal to 0. So the cubic root of x is minus 1. Cubic root of x is positive 4. But notice the cubic root can be negative. And so here I can safely just cube both sides. So 1 cubed, negative 1 cubed is negative 1. So x can equal to negative 1. And 4 cubed is 64. And so these are my two solutions. And so once again, here for these problems, it gives you the substitution. Just plug it in. You're going to get a normal quadratic. Solve it, factor it, and then write u plus whatever equals 0, u minus whatever equals 0, or u, and then plug back in, and then just solve the equation from there. Okay. And if you have a square root, you can square both sides as long as one side is non-negative. And then if it's an odd root, like here, a cubic root, you can just cube both sides and you're clean to go. All right. Okay, so let's go and see where we're at on our little happy list. So layer 1. Okay, so we've done on this layer. So we've done this, this, and this. All right, so you want 15? Okay, so let's do 15, and then, yeah, we'll keep going. Give a new layer. Okay, so here we have 3, 2, 15. And so this is the formula. So S is equal to 16t squared is the distance of an object in free fall. And I'm dropping a ball say from a height of, in this case, it's 205 feet. Your feet will be different than my feet. So if some person is dropping a ball, how long does it take to hit the ground? Okay, so I have 205 feet is equal to 16t squared. I just want to know at what time. So I know what my S is. I want my distance to be 205, right? My units here are feet per second squared. That's what my units are for acceleration, feet per second squared. And so time will be in seconds. So I want to figure out this. And so here I just take 205 divided by 16. And I get t squared. And then I take the square root of that. So let's do that. Let me open up Wolfram Alpha because I do want a computer program to do this one. Oh. So Wolfram Alpha. Yep. All right, so I'm going to show this. So I'm going to take 205 because that's how many feet I fell. So basically, I want to solve this equation. 205 equals 16 feet at 16t squared, right? That's basically what I want to solve. You can just have it, solve it directly. I'm sure I'll solve it for x like a good person would. Yeah, say I can do this. It'll solve it directly. So I get approximately 8.6, which is the correct answer. Or I guess you need to round up. So it'd be the 8.7 would be what you type in. And notice you can throw away your negative one. Now, if I was going to do the step by step, so let's do step by step real quick so you know all the steps. So the first thing I'll do, divide by 16. So I get 73. I get 73 point that. And then I just want to take the square root of that, SQRT. And since we're talking about positive time, it doesn't make sense for the ball to hit in negative time. And so we'll just get this answer. Okay, so that's how you solve that one. You just, here's the equation. They tell you what S is, so they plug in S of 1205. And then, so you just divide out 16 and take the square root. That's all you need to do for that one. Okay. All right, so let's open up the last one. And let's do a couple of those. All right, let's go ahead and do preview. All right. So the first one was 10. Okay. Let's show completed answers just for funs. Oh, this is gonna be all right, let's do this one. All right, so what is this? Me a new one. All right, so now I'm doing 3.3.10. All right, so it's going to ask you the following. So here it gives you a function of f of x is equal to minus 8x squared minus 8x plus 1. And it wants you to find the vertex. And it wants you to find, say, whether the parabola is opening upward or downward and what's the maximum value, the range. And then it also wants you to say where it's increasing and where it's decreasing. Okay. So the first thing we want to do is find the vertex. So this would be minus b over 2a. So in this case, our b is b minus a minus 8 over 2 times a minus 8. So I have minus, minus, minus. So I'm still plus. The 8's cancel. So I have minus a half. Okay. So minus a half is that value. I plug that into the function. So f of x of 8 times minus 1/2 squared minus 8 times a half, or minus 1/2 plus 1. So notice that this, go ahead and do the math here. So this cancels with this. This turns into a fourth. And so a fourth times an eighth will give me 2. Make sure I'm doing this right. Oh, hold on. This becomes positive. So this becomes positive, so I have minus. So this becomes minus 2 because this is a positive fourth times a negative eighth will give me minus 2. Here I get this will be plus 4 because this will be minus minus, so it would be plus 4 plus 1. Did I write this? Hold on. Somehow I'm not getting the right number. This is 5 minus 2, which is 3. No, I'm getting the right number. Okay, so I have my vertex. So my vertex here is a half and 3. So that's my vertex. The parabola opens downwards. Since this is negative, it opens downwards. So it opens downwards. And it has a max at 3. Okay. If this was positive, it'd open upwards and have a min at 3. But this is negative. The other thing it wants to do is it range. So since this opens downward, my range is going to be from minus infinity to my maximum, 3. And then I just go ahead and block that in. We talked about this before. If it opened upward, you're going to go from your minimum to positive infinity with the brace. And then it wants to know where it's increasing or decreasing. So it's going to be increasing up to a half, right? So it'll be increasing from minus infinity to the half, not including it because we don't, and it's decreasing. So it's going to increase up in here because this is at a half 3, right? So that's the point right there of my vertex. So it's increasing up to that. So minus infinity to the, minus half. Sorry, it should be negative half. And it's decreasing from that minus half parentheses because we don't include the point all the way to infinity. Can I go slower? Not if I want to finish all the problems before I have to teach office hours. So it's kind of a give take. I'll be posting the video so you can go back and rewind it. I get it. I was like, I got 5 more minutes before I need to switch over to office hours contractually. So yeah, I did go and kind of go through that. Just a quick review. For this, you just find negative b over 2a. And so here, if I plug that in, I get the half. You just plug this back into the formula. So here's my formula. So I just plug in, everywhere I see an x, I'm going to plug in negative half, crunch that through. Use a calculator for this. Don't do this in your head. You get 3. So this gives you your vertex. Since this has a negative a, it's going to open up downward and have a maximum value. What's that maximum value? It's just whatever this y coordinate is. The range here is from negative infinity to that when it opens downwards. If it opened upward, let's just pretend for a second I had a positive 8 squared. If it opened upward and I still got whatever this was and I got minus a half, and let's actually make it look different. So I'd say I got a 4th and 7. I don't know, right? This one would open upward because this is positive, and so I'd have a minimum value at what? 7, whatever this is, right? And then my range would be from 7 including to infinity, and then it would be decreasing from here to the point. So it'd be decreasing from minus infinity to a 4th all the way, and then increasing. So it's just the opposite of what we did here. So this should be able to solve all those sorts of problems. Okay. All right. So let's see where I'm at. All right. I think we should have time to solve at least 2 of these before we go. So let me go back to my big, huge list of layers. All right, let's go back to layer 1. So we've done 10. we're going to do 11 and 12, hopefully, and we probably won't get the 13, but doing 11 and 12 should get you close enough. All right, how? So let's do 10. 10 says I throw a ball upward with a velocity of 28. So there we go. So some guy standing on a platform of 8 feet tall, he throws a ball upward with the speed of 28 feet per second. And gravity is always, and gravity pushes it down at minus 16 feet per second, or t squared. So what is the maximum height of the ball? So here I have s of t, so s is my height, is equal to minus 16 t squared plus 28t plus 8. Okay, and they give you this formula. This formula is given to you. You don't have to calculate it. So basically, someone's standing on a foot of 8 feet, they throw it up, and they give you this formula. If I want to find the maximum for this, what do I want? Well, max. If I want to find a max, that means find the vertex, right? I want to find the vertex of this thing. So x is equal to minus b over 2a. Well, in this case, b is 28, so minus 28 over 2 times 16, or minus 16. And so if I crunch that through, I do not trust my little brain right now. So we're going to just use the Wolfram Alpha wherever I hit it. Where did I hide that Wolfram Alpha? That's fine, I'll just open up a new one. Wolfram Alpha. All right, so here, so minus 28, so minus the minus, so this will be positive. So let's just say 28 divided by 2 times 16. Okay, so that gives me, so that just translates into 7/8. Okay, so that's 7/8, or in decimal form, 0.875. And so how do I find the maximum height? I just plug in 7/8. So I crunch that through, so it'll be minus 16 times 7/8 squared plus 28 times 7/8 plus 8. Crunch that through a calculator. And that'll give you 20.25. And so now I can answer the question. What's the maximum height of the ball? So the maximum height is 20.25 feet at 0.87 seconds after it's been thrown. Okay. All right. Yeah, we got time to do the last one. We'll do one more. I know it's a lot of homework problems really fast, but you can slow it down and rewatch it. I do want to answer all these questions. Now, I do feel kind of bad because now you're not going to have that many questions asked on the homework, right? So find the sum of the base. So the sum of the base times the height of a triangle. So here we have base plus height of it. So hold on, let me write down which problem I'm working on first. So this is 3.12. Last one was 11. This one will be 12. So I know the base plus the height of the triangle is 22. And now I want to find which dimensions is the area maximum. So here I'm going to solve. I'm going to say base is equal to height plus 22, or 22 minus the height. And the reason I solved this for this because it's 1/2 base times height is equal to my triangle. It's my area of my triangle, and I want to maximize this. But I know what h is, so it'll be 1/2 b times, oops, I know what b is, so it'll be 22 minus h times h. So here I have 1/2 Let me do this slowly. So it would be minus 1/2 h squared plus 11h. Yeah. Okay, so that's why we wrote it that way. And I want to maximize this. So notice that this is a formula. So this is my area. So I have my area here is minus 1/2 h squared plus 11h. So how do I do this? I know that my base times my height, if I add those two up, I get 22. So I'm going to solve that for my base. Then the area of a triangle is 1/2 base times height. So I plug in my base, so I get 22 minus h times h. This simplifies to this. Once it simplifies here, I want to maximize this, and so I'm going to find the vertex. So x, or in this case, h is equal to minus minus 11 over minus 1/2 over 2. So that cancels, and so I get 11. And so if I know the height's 11, 22 minus 11, I know the base is 11, and that's all it asks. And that makes a lot of sense. You want your height and your base to be the same. Okay. Well, sad to say, that's officially the end of class. I got to swatch over the office hours. I'll post this video. So that goes over like a lot of questions. So I'll post this video today. Depends. And I'll start making and doing that. Good luck, guys, with the homework. Any other questions, go ahead and ask your classmates. That's what the discussion board is. I hope this was the best way to use our time for the day. Instead of doing extra notes, I figured let's just get you through some of these nasty problems on this homework. Okay?